but I have greater problems. Here they are. So the first thing we want to do when we encounter one of these radical equations is make sure any radicals we have are isolated, like we have here with the square root of x plus 3 equals 7. Since that radical is isolated, we can square both sides. Root disappears. We've got x plus 3 left. Equals 7 squared, 49. Got a simple linear equation to solve, so x here is going to equal 46. For good measure, you take that 46, you plug back into the original equation just to make sure it works out, and also make sure there's no extraneous solutions. But 46 works here. Slightly more challenging, you've got 8 minus square root of 4 minus y equals 0. If you want to make sure the radical is isolated, then you could do one of two things. You could subtract the 8 over, but then you'd still have this negative here you got to divide by. Or you could just add the root over. 8 would equal square root of 4 minus y. Once the radical is isolated, square both sides. 8 squared, 64. Root's going to disappear. Got 4 minus y left. Could subtract 4 over, get 60. That equals negative y. Divide by the negative, y is going to be negative 60. Once again, you go back to the original equation. You plug that negative 60 back in, make sure it works out. Make sure you don't have extraneous solutions. In this case, we don't again. Okay. Start to mix and match a bit on this one. Y plus the square root of y minus 3 minus 5 equals 0. It may appear a little bit differently. In fact, you got a y under the root, you got a y outside the root, but the strategy remains the same from the start. You want to get that root by itself. So getting the root by itself, that's square root of y minus 3 here. I'm going to add the 5 over and subtract the y. So add the 5 over, subtract the y. At this point, if you square both sides, to eliminate that root, well, you're left with y minus 3, and then you have a binomial you got to square. So take 5 minus y, multiply by 5 minus y. Get 25 minus 10y plus y squared. So radicals disappear here. We're not left with a linear equation. We're left with a quadratic. So we follow our rules for solving quadratic equations, which involve getting 0 on one side, right? Everything else on the other side. Got my y squared over here. I'm going to subtract over this y to that negative 10y. It's negative 11y. I'm going to add the 3 over. Adding that to the 25, get plus 28. We got something factorable here. Looks like 7 and 4 could work, right? In fact, everything's minus. So set each factor equal to 0, solving for y. Y would be 4 and 7. Got to check. If you plug the 4 and the 7 back into the equation, do they work? And I can take the square root of 4 minus 3, right? I can take the square root of 7 minus 3. Appears we're good. If you check a little more closely, you can take the square root of 7 minus 3. That's okay. But plugging in for 7 here and then actually putting everything together causes a problem. So 7 is gone. Yeah, on this one the radical expression is not completely isolated, but it's isolated enough where if you square both sides, radical will disappear. As I square the expression over here, 2 squared got 4. I'm understanding that 4 is being multiplied to the result I get when I square the square root of x plus 5. You know, the radical is disappearing there, so that quantity would be x plus 5. That equals x plus 2 is a quantity squared, so x plus 2 times x plus 2, get x squared plus 4x plus 4. All right, distribute the 4. Got 4x plus 20. Got a quadratic forming. However, if you start joining your like terms and you try to set everything equal to 0, now let's see, you got x squared. The 4x comes over, cancels the other 4x out, right? And then I subtract over the 20 from that 4, get negative 16. So you could factor as a difference of 2 squares if you want. Or if you want to, you could add the 16 back over and take the square root of both sides. But remember, taking the square root when you solve, you got a plus or minus that you got to be considerate of. Either way, x should equal 4 and negative 4. Now, if you check to make sure each of those work, do each of those work? After plugging in and checking, negative 4 does not work. It does not yield a true equation.